Hey everyone, thanks for joining. Sorry I'm a little bit late getting started today, but let me bring up the agenda here. Okay. So as I'm editing this document, I noticed nobody nobody entered in any agenda items for today. Um, I'm looking at the participant list. I think everybody's been here before, but let me do the quick rundown. This is the device security / kernel SIG call. It's a supplement for mailing list discussions. This is the ostensibly Europe-friendly time to try to catch people in Europe before they go off for the weekend. But yeah, means recorded, and everything you say here is probably things you would also have no problem saying on the mailing list as well. Before we get started, I usually give a chance for people that are new or haven't had a chance to introduce themselves to the group. They can go ahead and raise your hand, and you can just give a quick introduction about your name, your organization, and your interest in participating. So let me go ahead and open that up if anybody would like to do a quick intro that hasn't had a chance in the past. Okay, Mehmet, if I'm saying that correctly?
Yes, that's right.
Yeah, go ahead.
Hi, I'm Mehmet. I'm with Atlas Computing. We're a formal verification outlet in a, say, foundation. And I am actually not doing formal verification. I'm working with a group working on flexible hardware-enabled guarantees, sort of like enabling device security features for just compute governance and ISP. And I'm just here just to observe honestly to see how consortia tend to work and how standards actually get made.
Okay. Okay. Yeah, you're definitely welcome. I will say that this is we're more of an ad hoc group. We're a bunch of opinionated kernel developers trying to decide what all these different platform technologies mean to the kernel, and how do we kind of uh, gel them into a common solution. So it's a little bit less. It's probably the least formal of all the computational computing working groups, and this one is definitely more practical and uh, and practical focused and wrestling with the issues as they apply to the Linux kernel. So, but
Okay,
yeah, but you're definitely welcome to attend.
thank you so much.
Anyone else? And if not, let me open it up to any live agenda items that people would want to bring up. Thank you.
So I don't know if this is a discussion that we're ready to have now, but um, I think sooner than later, it's probably a good idea to tackle um, what measurement formats the kernel is going to return, or if we handle it kind of like the way file systems handle, file paths. It's just an opaque blob, and you leave it to user space to decide what the encoding of that blob is. Because as of right now, the CMA work is breaking out DMTF measurement blocks into sysfs files, which it's questionable if it's a good idea to be parsing that measurement inside the kernel where it's coming from potentially a hostile device. But if that's the direction that's going to go in, it just means we need to do extra validation on that. But for everyone else, like for example, if you're going to put this in, get this measurement and send it to Intel Trust Authority or NVIDIA Remote Attestation Service, NRAS, they're not going to want something like that, right? Then we either need to say it's an opaque blob and it's up to the user space to go, this is coming from this device. I know this device talks this, we'll send measurements back in this format, or maybe have the kernel say, here's an opaque blob of the measurement. Here's a field that tells you what type of format it's in, whether it's in, CBOR or JSON or, the DMTF raw measurement, whatever it is. We probably have a discussion about that at some point.
Yeah, no, I think now is definitely the time because we're wrestling with that question. But is it? I know the oh, actually, go ahead, Samuel.
That is something I wanted to, didn't have time yet, but comment on Lucas' patch set, that we're not exposing the DMTF measurements right now back to user space. But is it maybe it's a naive question, that why would the kernel actually parse those measurements and try to make something out of it?
So my understanding based on the patch set was that there's a proposal to have that parsed and broken out into SysFS, a SysFS hierarchy, because some customers have asked for that kind of functionality.
Yeah, I think I missed that. Is that on the V2 patch set from Lucas that's been discussed?
I think my understanding was that the only kind of end user that's been driving some of this is the kind of the SSD use case. Hold on a second. Sorry about that. Yeah, no. So the only hard use case I know about is the wanting to collect measurements from SSDs kind of thing. But that was, yeah, I'm not sure that fits what we need for the TDIS case. And so yeah, so it makes it very straightforward to collect an inventory of, hey, these are my SSDs in my system, these are their firmwares, and these are the signed measurements from them, and cat those files and pipe them over to OpenSSL. But it doesn't take into account any of the requirements that we really need on the TDIS measurement evidence verification side.
So Dan, just to clarify something, the measurements that we get from an SPDM device, OpenSSL wouldn't. They're completely separated from their certificates from the device, and basically the measurement is typically something that you would use for running remote attestation or local attestation, but basically attestation of the device itself, not measuring, not verifying its identity or authenticity, but basically verifying its measurements.
Exactly.
So OpenSSL wouldn't have. It would typically be something that a knowledgeable user space piece of software would parse and combine that into something that a remote attester would be able to verify.
But I think the idea was that OpenSSL was an easy and available tool on most systems to be able to take, so when you do the get measurements request for SPDM, you can ask, give me a signed measurement, right? And you be able to verify that signature on that measurement is correct.
Yeah, sure. I think so. You can verify that the measurement is trustworthy, but the measurement itself is something that I don't think the kernel would be able to. As you say, I think parsing this kind of opaque blobs from the kernel would be challenging, if not risky.
Yeah, because there's no guarantee what the device is going to return.
Yeah.
SPDM says, So technically, the 1.3 spec for SPDM only defines the DMTF measurement right now, right?
Mhm.
And it has some reserved bits for other measurement types, but it doesn't codify, say, a concise evidence measurement for SPDM bindings as a type of SPDM measurement to return.
Yep.
Now, it may change in the future, but as of right now, technically, SPDM only supports one measurement type. So you can
Actually,
assume everything will return that, but in reality, a device could return something else because SPDM and TDISP are separate standards, and because of that, if you do go the additional mile and support TDISP over SPDM, and you have a compliant DICE engine in your device, and you actually make a DICE compliant measurement, the format's going to be different, right?
yeah, and TDISP runs on top of SPDM, but it completely it's kind of orthogonal to the measurement of the device itself. It doesn't preclude or exclude any of this.
Yeah, the way they formatted in the spec is SPDM is built using TDISP is built using SPDM and IDE as the underlying technologies, but it is a protocol that rides on top of it for device attach and detach. And for example, the TDISP report structure is separate from the SPDM measurement structure. Those would be two separate calls. So I guess that's another question for TDISP. Do we have two separate interfaces for that, or do we just have one common device measurement? And if it's a TDISP, you get the TDISP report and the SPDM get measurement response, or do you want two separate nodes for that?
I believe we should have two separate nodes because they're really two different things.
Yeah,
they don't provide the same security attribute back to user space. So
I agree.
Can I just confirm? Has Lucas posted anything about measurements? I thought so
No, he
far the
hasn't.
only stuff, was SysFS for certificates and stuff.
Exactly.
Okay.
That's what I was mentioning. That I think it would be good to maybe leave some space for, or at least say that we may also want to expose the SPDM measurements back to user space.
Well, we definitely need to
interface.
expose the SPDM measurements to user space because something in user space is going to need to get that measurement and hand it off to a verifier. The question is, what is the format of that thing that's being handed back to user space?
You want to add an attribute for describing what is deep. I mean, it's going to be DMTF for now, but it could be something else depending on the SPDM protocol.
Yeah. I mean, so I'm heavily leaning towards the fact that the kind of the things that the kernel needs to do for CMA and the way that the kernel might make CMA easily digestible by user space is not the direction that's going to really support what we want to do for TDISP. I think so. The question then becomes, do we build a parallel universe that's for TDISP, or do we make the CMA thing step back and not do that base level of parsing and put more of a raw interface, independent, like format independent kind of blobs out to user space and let it put it back together, whether it's CMA or TDISP. And I'm leaning more towards that, that it might be good to kind of keep the locations of these things the same for, like, hey, if you want to get some security data for a PCI device, here's the path. But in terms of the format and what's contained in there, you can't assume that, and user space is responsible for knowing this is CMA, so it's a DMTF format. This is TDISP, so this might be DICE format, and kick that problem out of the kernel.
Yeah, the problem is CMA is a completely separate section of the spec from the TDISP stuff. So like they're two orthogonal features that just happen to use SPDM, right? So I think you could still use the TDM concept that was proposed to have the user space verifier still do the acceptance of devices for CMA. The only difference, we just need to figure out a way to communicate to the TDM and user space. This is really a CMA request and not a TDI management request.
I'm almost thinking that we build exactly what we think is what we need for the TDISP case, and then see if there's any possibility of unifying that with the CMA side. And if not, then they do take two parallel paths and we don't try to force things to fit together that don't naturally fit together.
So Dan, what is your biggest concern for the current? I mean, I have a few concerns about the current proposed patchlet from Lucas, but overall, the CSFS interface that he's proposing, assuming that we could also add a set of measurement nodes for exposing the SPDM measurements. I mean, we could have a unified CSFS interface between the TDISP and the non-TDISP case for those. And
Yeah.
I'm just wondering what's your concern on that.
Well, yeah, I mean, it's like I guess we're saying the same thing, because you're saying, hey, add a few more nodes for the TDISP case, and that's to me that's saying we're going to kind of build a parallel thing that's in this, maybe in the same directory, but it has different formats, a different it's just a raw blob that comes out. So it's not, we're not trying to force everything through this exact same CMA files. We're saying,
I see.
Here's the directory of this evidence. Here's the things you're using if you're kind of doing CMA, and here's this other thing that's TDISP, but it's the same. I guess we're using the same infrastructure, but not the exact same files.
I see.
Yeah, which is why I commented to Lucas when I met with him that if we have a customer that wants these fields broken out so it's easy for them to inspect it and verify it, although to be honest, if the whole I guess you still have to trust the kernel for that, because the kernel is populating those sysfs fields for what is the hash for this measurement index, things like that. But everyone else wants the whole measurement that they're going to probably package up into maybe even a platform-wide measurement to then send off to a verifier somewhere. So, for example, I think it was at the last Confidential Compute Consortium conference, there was a talk by Intel and NVIDIA on a unified measurement for H100 and TDX. And so they were actually making two separate calls. They were making the NVIDIA call, they were making the TDX call, packaging it up into a blob, sending it off to Intel Trust Authority to do the verification of it, right? So you could see that for not just, multiple graphics cards or other accelerator cards, but even if you want like a more in-depth platform measurement rolled up into the verification as well. So getting any sort of individual fields getting that opaque blob seems to be more of a useful thing. Which, if they want to break it out into individual measurements, fine, but we definitely need that one field that says, here's some bytes that the card gave me for the measurement. You need to figure out what to do with it now.
Yeah, I mean, and that's exactly the same philosophy we took on the kind of the CPU based platform report. It's just here is the place in Linux where you go to get the blob for your platform. And we don't know what it is, but hopefully your verifier does, and see the kernel out of it.
And there's literally no difference between. I mean, I don't think it should be treated differently when you get a measurement from your CPU, your platform CPU, and from a PCI device. It's really about the same thing when composing those into something that describes your entire platform CPU plus devices. But there is fundamentally no differences between the two. So exposing them as just opaque blobs with some information about the format as hints, nothing else. I think it makes a lot of sense.
The problem is I didn't see anything in the TDISP spec that would allow you to specify this is a TCB info struct as opposed
You mean
to
in the SPDM spec?
No, the TDISP spec, because TDISP is where it comes in that says if you support DICE, you really should be giving a TCB info back instead of a DMTF measurement. SPDM is pretty straightforward. It has the field for what the measurement type is there. But if you look further in, if you look through the spec for TDISP, it says at some point, if you support DICE, you really should be returning a TCB info struct measurement as opposed to a DMTF measurement. And then there's a separate TCG document that says if you're going to return a TCG measurement instead of a DMTF measurement, here's how you bind that SPDM measurement in DMT format to concise evidence that you'd return as part of your TCB info.
But at the end of the day, what you're receiving is, I mean, it's coming through SPDM, and it's going to be it could be a TCG info embedded into a DMTF format, but or bound to it. But that, I mean, you're going to get that from SPDM, not from the TSP state machine.
Yeah, but if unless you specify DMTF format in the get response, in the get measurement response,
Yes.
it's not guaranteed to come in DMTF, right?
Oh yeah, yes.
Yeah. I think this is an area where they need to clarify it in the PCI specs, because right now it's very confusing how you would tell if a device was returning anything other than a DMTF measurement, and there's no standard as to what those would be. So there's nothing in there that says, this is a TCG measurement instead of a DMTF measurement.
Yeah.
And I don't know. So I think we have some unfortunate wiggle room here where it's not clear what the answer is.
Could be a lot of different formats, but yeah.
Yeah, because it could be more than a CBOR measurement or any of those things.
Yeah. Silicon vendors are pretty good at coming with custom formats.
Yeah.
But I think, I mean, I'm not hearing any dissent from the proposal to say let's go build what this opaque blob interface looks like, and then
No.
and then after we build that, we see like, hey Lucas, like if we're gonna have this raw blob interface anyway, why does CMA think it needs to be more fancy or more precise and try to break things out, and just let it also do raw blobs and push the whole problem to user space?
Yeah, just returning the bytes of the get response message. Like, there's nothing sensitive in that get response message. Not the nonce, nothing. So at least I don't think the nonce is particularly sensitive there. But you could return that whole message, bytes and everything, just to user space, and then have the libspdm and user space be responsible for decomposing it, looking at what the measurement type field is and everything like that.
As long as you can authenticate the response and verify that it's actually coming from the device that you authenticated, then that's
so
all
you
you
should
need
be able
from
to,
user space.
if the certificates are exposed, you should be able to do that by looking at the certificate, checking the signature on the. I think we would then have to require that get message requests are sent with the request for it being signed in the response. And I don't know if that does that already, but I think it's also up to user space to make that decision, right? Whether it wants to trust an unsigned get measurement response or validate that signature against the certificate.
Can SPDM do an unsigned measurement response?
There's a bit you have to set to get a signed measurement response. I'm pretty sure. I remember seeing that in the spec. I'm not sure if it's set by default and you'd have to unset it, but there is a field in the request to say I want this signed.
Isn't that an optional thing that the device could say, no, I don't sign those. I don't need to, because you got this over my secure session, so you should just trust the session and not the signing. Isn't that one of the problems?
Yeah, the session is protected between the.
Yeah, but the problem with that is then a third party has no reason to trust that measurement, right? A local user space verifier could say, okay, this was done over a local SPDM negotiated session. I can trust it. I don't need it to be signed. But if you're then going to take that evidence and then pass it to another entity to verify without a signature on it, that third party has no reason to trust what you sent it.
That's basically a difference between an evidence and a set of measurements.
Yeah,
an evidence is really like authenticating your measurements.
Yeah, but that's really not the. I mean. So the kernel should set that bit if it can't get a signed thing. That's really not the kernel's problem. It is the verifier. The verifier's job is to catch up. Like, oh, hey, there's no signature here.
Yeah. So I think the better secure by default response is to request a signed measurement back from the device. If the device can't do it or doesn't choose to do it, then it's up to user space to go, okay, I request this is supposed to have a signature on it. It doesn't have a signature on it. So I will then make a decision locally on what to do with that. And it may be the decision is, I'm going to wrap this up into a larger platform measurement, a platform piece of evidence that I will sign with my certificate that a third party can trust, or just use it locally. There's a lot of policy and decision making that is rightfully deferred to user space here. But I think by default, we should always request that the get measurement request is signed, response is signed. And then, it's up to user space to decide how to handle when it comes back with an unsigned measurement response.
I would, in the first instance, just reject it, don't present it. So, I mean, let's wait until that's an actual problem. Because hopefully all sensible hardware will be able to sign its measurements.
Yeah, I don't know if that's a requirement in the spec to do it, but yeah, I agree. Anything that's touting that it's supposed to be TDIS compliant or SPDM compliant should be returning. It should have the ability to sign measurements.
It's had to sign a bunch of other stuff to even get the negotiation to finish, to get the link up. So, I mean, it's got sign-in hardware and it's capable of doing it. It'd be a bit odd if you didn't do it on the measurements.
Yeah, and
I agree. I don't think the spec requires it.
Yeah, and it has a unique device secret that it can build an identity off of, even if it's not like technically a DICE compliant one, right?
Yes, yeah. It might.
So
not
it has all the parts to do it. It's just a question of, is the device manufacturer being lazy or not?
It's SPDM. I mean, the spec itself is not really tied to remote attestation or certainly not confidential computing. And I think this is a case where, you have the confidential computing versus just raw CMA use cases. In a case where the host sees a CMA device, establish the SPDM session, and then you as a user space application, you can trust your host. That's part of the threat model. But in the computational computing case, you use SPDM to get measurements, but you really do want them to be signed, because you're not going to do anything with your measurement but send them to an external verifier or a remote tester, and that doesn't make any sense to send it without the device signature, because so it's kind of two different use cases, I think.
Yeah, I agree. I wonder if the device is well within its rights to return an error if you request it to give it a signed measurement and it can't. I'd have to look at the spec to see that, because that request that I had, that we always request a signed measurement, might be fragile, I guess, for lack of a better word. Because if the device can just say, I don't support it, and return an error, then the whole thing falls apart.
I think it was okay though, because it kind of goes back to Jonathan's point of like Linux is playing the role of, hey, the spec said should, and Linux said no, that's a must. And if you don't do it, then you get to keep the pieces, because it doesn't make sense to not do it. So I think it's okay for Linux to be spicier than the base spec and say, you're out. Linux actually requires that you do this, and so talk to your device vendor to get this fixed up, please.
Or another option is in the same SysFS node that you get the measurement from, you could also have a flag in there that you could set to request signed versus unsigned measurements. So if you have a device and you have to use that device, but it will never return signed measurements, we don't want the whole thing to fall apart, right? Especially if you're in the CMA use case where you're using it locally and you're not passing that measurement off to anyone.
That is true, but kind of the Linux ethos is do the right thing until somebody screams, and then figure out once they scream to say, hey, ours doesn't work. Then we'll do the quirk. But yeah, we don't we try not to imagine things and then mitigate them early until they become a real problem in practice. But yeah, no, but point taken. Like, we might get to the point where we need to quirk this somehow.
Yeah, code without users gets removed, basically. So if there's no one saying they need the feature, why bother putting it in the first place?
Correct. Yeah.
I think one very odd situation would be when the device exposes a secure CMA, secure SPDM, and would decide not to sign its measurements, or say it's not capable of doing those. Because if it can do secure SPDM, then it can sign stuff with its own keys. But there are CMA DOE mailboxes for non-secure SPDM, and I think this is what this whole use case is about, for devices that just use SPDM as a transport mechanism, not secure SPDM, where you can't challenge the device because it's kind of not very capable of doing this.
Yeah, it's just a transport, not a.
Yeah.
It's not trying to be a computational computing
Exactly.
client device. Okay. So that was a really good topic, David. Yeah, I think it's timely to bring that stuff up.
So do we meet with Lucas and relay to him what we discussed here, or do we, when Lucas posts his next set of patches, just add it as feedback? Or
I mean, I think the strategy I would take is we just build what that file looks like, because it's and then then go back to him and say, look, like I think we can solve all these use cases if we kind of drop some of this complexity or this not complexity, but like I call it sophistication of like parsing it and making it easily digestible by OpenSSL. That's interesting, but not sufficient.
And we could always just publish it, like the kernel allows us to publish a user space tool along with it, right? If we really wanted that functionality still in user space to be able to pull individual measurements out of a DMTF block, we could write an application that does that and ship it with the kernel.
Yeah. That might be the peace offering if Lucas really dead set on keeping that functionality around. We can say like, look, hey, here's a simple user space application to post-process the same thing and get you what you want while also supporting the TDIS use case. Yeah, this is pretty bog standard upstream back and forth discussion. I'm not too worried about getting that getting that aligned with Lucas.
I mean, there's still the point here that Lucas currently isn't proposing anything about measurements. He's only proposed breaking out the certificates, which is absolutely valid because it lets you look at what came in on each individual sequence to get to the point where you've done the authentication. That
but
stuff is all well documented, and that's standard. That's all SPDM stuff. It's nothing to do with measurement formats.
That's true. But he does have something around the transcript being merged in, or not being, or being separate, and we're trying to say like, the transcript and everything probably needs to all go together in this one big blob.
You might want that as well. The separate transcript is somewhat useful. The bits that he's broken out. Yeah.
So we might end up with both. That feels like it's overhead, but it's also, who cares? Yeah, maybe just do both and be happy.
Yeah, it was also my understanding that someone had proposed what the measurement interface looks like at Linux Plumbers. Was it last year? Or was it Linux Security Summit? One of the two. And that's the assumption that Lucas was going off of for what measurements was going to look like. That it was a broken out structure like that, as opposed to one large thing.
Oh.
And he did say technically we have something at the moment for that. The transcript has both the request and response of the get measurement call in it, but then you'd have to fish around in the transcript and find what you want from there, where it would be much cleaner and probably easier for everyone if it was just in a separate node.
Yeah, I think that was his reaction to James Bottomley's comment about allowing user space to verify the nonce and all these things.
Yeah, but that was still not the measurement. That's the initial sequence to get to the point where you can take a measurement.
Okay.
So that was the stuff James is interested in, is proving that you did indeed validly get up and verify you were talking to who you said you were talking to, not what state is the device in. Now, you might argue, you might want to wrap all that up with the measurement as well, but it also needs, in order to do that step and be able to run OpenSSL on it and verify by hand that you got everything you wanted, it does need to be broken out. I'm sure you could do it as a big blob with a massive transcript in it, but you've got quite a few of those because you've got to do for each of the different cert chains. So maybe.
I mean, do we expect like in the CMA case where it's like we have a native kernel ring and the kernel is doing certificate parsing? There's a reason for the kernel to have that knowledge, but for the TDIS case, a lot of this is not. The kernel doesn't care about it. Even and user space is just a transport to pass it to a verifier. It's a bit different use case, right?
I would say that the kernel, to a certain degree, still cares about it, even in the TDIS case, because you may not want to go to the effort of solemnly launching a confidential VM on your system if the hardware is completely different from what it's supposed to be. So there's definitely a case that you would want to have a look-see at what went past for the very basic, like who's there. Sure, it's not the formal path for checking security or any of that stuff. But you may, from a kernel point of view, want to have a look because you've got stupid questions like making sure, I don't remember what you need. You've got to pick the right key for which one's used for IDE. So which cert's used for IDE, because otherwise when you get all the way up into your confidential compute thing, it says, no, I don't like that one. So I don't think so much that the kernel would necessarily look at it, but something running on the host might. Just because admin stuff, it's not security related. It's if you've decided you're going to use key slot 7, you want to check that is indeed the one that has the key or the certificate chain that everyone's going to be happy with.
That makes sense.
So you're saying some basic verification from the host.
It's kind of more
not really
admin debug rather than verification as such. Well, probably not even the kernel, but presenting that evidence not that evidence, sorry, that's the set of sequences, basically what certs has the device got. Is it potentially a useful thing? And for the point of view of working out, someone has to tell the TSM or whatever, use cert slot 6 when you're establishing IDE. Now, that isn't logically the confidential VM, because by the time the confidential VM's up, your only choice is to tear everything down again. So there's a bit of policy there, and to make that decision, you can argue that, I mean, some people have argued that it's known to the orchestrator or whoever's bringing the platforms up in the first place that the certificate chain that it's expecting is in slot 6, and it just says, well, yeah, use slot 6 from the start. But you'd certainly, from a debug point of view, you want to go, oh, darn, on this device it's in slot 7.
But that does beg the question, like whether we need to have an interface, probably like a slot selector interface in the IDE or in the connection establishment flow.
Yes, no, absolutely. We need something. Some of the specs have it, so I mean, it does exist in. I think AMD's one certainly has a thing you passed to the TSM to say which slot do you want. And you get fun and games if the various confidential VMs that you're running on top of it don't like the answer because they disagree.
Right? Yeah. Like everybody, the host side agreed. We're doing slot 4, and all the guests are like, we want slot 5.
Or they want different slots. That's when it gets really fun.
Oh yeah. We want 5, and they want 4.
Yep.
I wonder how would the platform know about which key slot to use on each and every potential device that shows up on the PCI bus?
That's one of the reasons it would gather the measurements, is that so the argument I've heard for this is that if you're building a cloud running these things, you know. So all you do is you say, if you're using this device, when you send the initial stuff to bring up the confidential VM, you send that information as a record, use slot 5 without checking what's in it or anything. Now, from my point of view, chances of this working are pretty low because, yeah, okay, people don't always manage their fleet of machines particularly successfully and have exactly what they expect in each slot. So it makes sense to at least have the debug information so that when you try that, you can, yeah, sanity check. I'm just having a quick look. Oh yes, that is the slot, the slot I'm expecting. Otherwise, you rely on the confidential VM coming up and going no. And if this is, say, the network card, that confidential VM may have no way to report that it didn't like it.
Where is this on the spectrum of theoretical versus practical going to happen? Like how many devices aren't going to have just one slot, and that is the IDE slot? Like
I gather almost no one is going to have just one slot because the manufacturer's going to ship one and the cloud's going to fill another one.
Okay,
so there will almost certainly be at least 2 slots filled.
At least 2.
Because no one trusts hardware manufacturers, and hardware manufacturers think everyone trusts them. So, but beyond that,
we live in.
Yeah, I mean, I think you're allowed 8, but who knows?
Okay, but I mean, so we might never see 8, but like there's a strong case to say, well, we will see more than one, and then in computer science, when you see more than one, you might as well expect infinite. And then
yeah, exactly. Yeah. But I mean, this can be the opaque stream. It's just if we've got an interface defined for CMA that is simply chunking up the data as it goes by, then it might be useful. So I mean, it's just providing the different certs. Yeah, but certainly a slot selection interface is definitely a necessity. And as I say, some of the interfaces for what you provide from the host to the TSM include that as a field there to fill in. I don't know how we're filling it today, presumably with slot 0.
Okay, that's good. That's a good thing to keep in mind. So in the last 10 minutes here or so, I wanted to preview a patch I want to send out around the question of runtime updates of things that the guest has attested to. So we have this for devices. We also have it for the base platform. For devices, I think it's a bit easier to handle because you can in TDIS you can request no firmware updates, so you can basically lock down the ability of the device to change the firmware version that you measured previously, and so the guest has control there. And it's also the case that if you need to, you can kick a device out and bring it back in. It's pretty easy to be in full control of when the device might change personalities and coordinate that. The same cannot be said for your launch attestation for your platform attestation, like the from whatever technology you're on. And so I think at a minimum, the kernel is responsible for mitigating surprises. So if the kernel knows that this thing can change at runtime, it probably needs to tell you somehow, and it probably cares about just the transparency of, hey, this thing might shift underneath you if it gets updated. Do you care? And just at least have that level of transparency. As far as I know, even within x86, we don't agree on that policy. I think one platform's like one side is, hey, don't surprise things. The other side's like, hey, surprises are fine. I don't know what the answer is for non-x86 architectures, but I think the kernel should probably have a unified response to this question, whether it's okay or not okay, or needs to be strict or permissive. So I'm going to send an RFC along those lines, so just to get the conversation started. But I wanted to just preview that question here to say, like, I'm asserting that I think that the kernel does care and should have at least have a unified response, whether and not do this kind of per technology decision. And we kind of talked about this at the last meeting as well.
Yeah, Dan, would this take your so I think you're alluding to upgrading Ucode and such. Would you also be applying the policy towards migrations?
Because migration is effectively a runtime update, right? Like you could say
they're very analogous, I think.
Yeah, they're very analogous. Yeah, so I would assume that whatever we come up with here would also add transparency around can you be migrated and what changes when you migrate and these kinds of questions, and yeah, it should be something that is at a minimum transparent to the guests. Like and probably a lot of guests are going to be like, yeah, we don't care, please update us, or yeah, please migrate us. Like we just want to keep running, and yeah, and so if they opt into that, great. And if they don't opt into that, they say, hey, you know what? Like there is non-zero regression risk. I know I trust all these platform components, but I need and until I've completed whatever verification I need to do of these new component versions, I'd rather die than have things change underneath me. I would hope that also this conversation yields those kind of actual real world people that say yes, that's what they want, because what we don't know, or what the kind of open question is it the case that somebody says never update me, and if you update me I'd rather die, like, which is the kind of extreme reaction, or is it the case that, hey, I'd like to see updates, but I'd like to know when they happen and have a window to verify them, and so it's a bit more relaxed. I can imagine both of those kind of use cases exist. So that's kind of where this RFC is going to drive to, like letting people pick between those levels.
If we're opining on possible feature requests, I think another possibility could be, could the platform provide a complete log of all TCBs that my VM has ever run on, which the customers that I interact with are typically not savvy enough for some seconds update to deal with an update, but they would enjoy some auditability of TCBs that are hit. So for asking for nice things, that's interesting, I think.
That's almost like a measurement transcript for the base attestation, right?
Yeah, like maybe your attestation quote now contains, oh, you were on this TCB number X, Y, and Z, and now you're on 27, and you've had exposure to all of those versions.
So then is the discussion about the kernel exposing this and letting user space completely decide if it wants to accept, say, a device that is going to do potentially runtime firmware updates, or are we talking about the kernel itself taking some policy decisions?
I think it's. I think we can immediately get into a very complicated situation where we're trying to build a mechanism where the guest can actually communicate with the module and coordinate updates. I think that this is more just about reporting, like, hey, this platform says it supports runtime updates. Hope you know about that. Hope you knew about that. Or here's the requirement to say, like, hey, every minute or so, please tell us that you're still okay with TCB if that's what you want the kernel to enforce for you. These kind of things. Because it's already the case that some shipping solutions already just assume that the guest is okay with updates, which I admit is probably the majority of use cases. But for the ones that aren't okay, they need to have the data.
Okay, so basically letting letting the guest decide if it's if whatever the device is exposing is acceptable to it or not on a per guest basis.
It's devices and the underlying ISA, so TDX or COBE dependencies.
Yeah.
Okay.
To be honest, though, there's no way for you to migrate a device when you're migrating the VM, right? Because there's enough that's host specific to that channel that the device has been attached with through TDISP that you can't migrate the device. So the only thing I've seen so far being the reasonable solution to migrate a device that's using an accelerator is finish your workload, finish your work unit, coalesce the data, detach the TDI, migrate your VM, request a TDI be attached on the other end, and then keep going. Now, if you're just talking about someone updating, say, the PF on a host, while it's local to the host still, then the only mechanism that the spec would allow you to use for that, I think, is to put the device into an error state. There's no mechanism described in TDIFs to notify the guest other than the error state that something in the configuration has changed underneath.
Well, there's no potential for migrating TDISP state. I'm confused about that, but I also have very little knowledge.
Well,
I was
so
under the impression we could move the device state between different devices and keep the TDI alive.
I would highly, well, I would not sign up to build that because I'm not sure that's going to work.
yeah,
But
so what technology does that currently? Because I'm not aware of anyone who has that in their ABI for their TSM. Is that something that AMD does?
and also this is also getting to the point where I remind people that, hey, if it's not publicly available, then we won't talk about it here. But yeah, if there's some public specs that talk about this, go ahead. But otherwise, if we're getting into confidential information, then we can stop here. But
yeah, well, the public TDX spec for migration is covered in the 1.5 documentation that's publicly out there, and it doesn't cover migration of TDIs at all. It just covers migrations of the I guess TVM, to use the more generic term.
Yeah. I mean, personally, yeah, I'm kicking the migration question down the road because we have so much of the base stuff, fundamentals to get right before we even think about how do we rotate the world around that baseline. But yeah, I had been assuming that for the device security side of this, it's a violent operation. You kick out the device, you have some kind of way to transfer massive amounts of state securely to another device, and then you replug the device on the other end and hope it all comes back together. I'm not aware of anything that's going to be any more graceful than that.
Because the issue is more than one device may use that IDE channel, right? Which means you can't migrate the key data for that channel and then keep the original channel on the host secure. So, yep. Single stream IDE is very much probably going to be a common use case for a lot of devices.
But yeah, step one is get a TDI in the TCB on one VM, and then we can talk. Okay, I haven't been watching the chat. If there's anything there that we wanted to review before we wrap up, but yeah. So basically, but I'll throw it open. Any other parting concerns?
Oh, Dan, I got a question. I'm not sure if you see my emails. Like, I see the version. The patches from Alexei actually is not based on your previous PCI TSM patches. So is there any plans like these two patches that are going to be aligned in the future?
Oh yes, they will be. So like, so I'm working through that, but that was the first thing I noticed. Like, hey, you didn't build on that. But at the same time, it is an RFC, so so maybe he was for I'll just say for probably for speed he was not integrating on top of that. But yeah, like that approach was acted by Bjorn. We put a lot of effort into it, and it's not something that we're backing away from. So yeah, so watch the list. I'm still going through the review, and we'll have the discussion on
I
the
see,
list there.
I see. Because I was thinking, what kind of help, we can offer, like, trying to picturing, like, how to fit, one part of these RFC patches into your patches. I was thinking something like that. Yeah, but I'm happy to know, like, there's a plan. Yeah, I see.
Yeah, I think the place that needs the most help or is that whole discussion about the guest MEMFD or IMMUFD interface for establishing these mappings, and
Okay.
kind of that feedback that Jason gave. I think that is probably the most, because that's beyond the kind of the TSM core thing that I've been proposing, and he's talking really about how do we enlighten VFIO for this, and I think that was.
I see. Thanks.
Okay, so yeah, so this is end of August. I had the Linux Foundation cancel our September meetings because we're hopefully going to see folks live at Plumbers in a couple weeks, and so yeah, I plan to be there. Hope to see some of you there as well. But other than that, yeah, we'll call it a day, and yeah, hope to see you in Austria.
Yep. See you in Vienna.
Yep.
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 See you, Vienna. Yep.
Okay. Bye, everyone.
Bye.